everyone, and welcome to our first video. Today I'm just going to go over lesson 1.0 and I'm going to talk a little bit about these lesson packages. So the idea is I like to give out a package of lessons at the start of every unit that covers the whole entire unit, and we work through them together by putting the note into the lesson, and there is some practice work that you're meant to do on your own within the lesson as well. And as you can see at the top of this package, I have a link to a homework package, which I won't print out for you, but you can have a look at that and you'll do your work on your own paper. I'll also have a link to this PDF document that will update with our live notes. So after class, once you leave, the note will be uploaded to a single PDF document that you can access from our PowerSchool page. And from this document. So I'll tell you all about that in class. But for today, I want to do this as a bit of an exercise, just in case we do end up learning from home. I do like to present my notes in videos sometimes. I find it pretty beneficial for students and for the teachers. Students like you can speed up the video if you want, or you can slow it down, or you can stop it if you want to copy stuff down. And I just want to take this opportunity to practice. What we're doing today in this lesson it should be all review for you. So I don't think there'll be anything new, so I think this is a good place to start for us in practicing a video lesson. Anyway, enough rambling. Let's move on to the actual stuff. So the first thing I want you to do is I want you to write your name. So my name is going to be Solutions. Okay, and what you're going to do also is write the date in here. So tomorrow, or our first meeting day, will be September 10th. Okay, and then once I'm done the video, I'm actually going to upload the link into this field. Okay, so it's not there right now, but it will be later. Okay, so let's get started. We're going to skip over this for the moment, but I'll come back to it. We'll talk about it in class. And let's get started with lesson 1, which is a review of important concepts from grade 9. So basically, the point of today's lesson is I want us to remember things like what a polynomial is, what an expression is, and just go over some definitions and some stuff you might be rusty with. Okay, so what is a polynomial? A polynomial is an algebraic expression that has this form here. Okay, so you can look on the page and you'll see some examples of polynomials. I'm not going to ask you the definition, but the biggest point here is that we can see that for a lot of these terms we have a variable like x, and we have a different letter like a, b, c, or d. So one of these things is the variable and the other one is the thing we call a coefficient. Okay, but that's the general trend of these. So let's get into some definitions. So first of all, what is an algebraic expression and how is it different from an algebraic equation? Okay, so an algebraic expression is an expression involving variables. Okay, so it's really important that we have variables in this. Okay, so let me give you an example. X squared plus 4 is an expression. How is it different from an equation? Okay, so an equation would be something like this. So the biggest difference between an expression and an equation is in an expression, the only thing you can do is simplify. But in an equation, okay, and by the way, we can tell it's an equation because of the equal sign. We have a left-hand side, a distinct left-hand side, and a distinct right-hand side, where we don't have that with an expression. And in an equation, the thing you're supposed to do is you're supposed to solve it, okay? So a lot of times, students will tell me that they solve an expression, but that's not actually true. What you're doing is you're simplifying. Okay, so that's the big difference between an expression and an equation. So in this example, for this equation, if I wanted to solve it, what I would actually do is use reverse order of operations. Okay, and then once I know that x squared equals 16, I know that my two answers are x equals 4 or x equals -4. So I can actually find the x values that make this equation true, which I can't do for an expression because there isn't a left-hand side and a right-hand side. What is a term? Okay, so this one is really important. We're going to be talking about it a lot this year and this unit. Okay, so what is a term? A term is a combination. Oops. Let's make this blue. Okay, it's a combination of variables and numbers. Okay, we call them coefficients. Okay, where the variables can be raised to the exponents. Okay, now here's the big deal about terms. Okay, terms are separated by plus and minus signs. Terms are glued together by division and multiplication. So the reason I didn't draw the signs is because division looks like this, right? It's a quotient, whereas multiplication can be a multiplication sign or it can be actually brackets. Okay, so let's do an example. So in number 3, I want you to pause the video now and decide how many terms are in the following expressions. And I want you to try it for A, B, C, and D all at once. So I'm going to ask you to pause right now, think about it, and then unpause, and we will discuss. Okay, so based on the definition that I gave you, we should know that in part A, there are 2 terms in this expression. Okay, 2x is one of the terms, 3y is one of the terms broken up by the plus sign. Now, for part B, what I would probably get as an answer is either 4 or 5. Sorry, 3 or 4 terms. I get that a lot. Some guys tell me I have 2 terms in this. But actually, the right answer is, sorry, I'm going to write the answer here. I forgot, 2 terms. The correct answer is there is only 1 term in part B. The whole thing is glued together. So even though there are subtraction and addition signs, the brackets glue that together, and the multiplication of the 5x glues it all together. So if you got that one right, hopefully you got part C right, which is also 1 term. Okay, and by the way, the numerator, right, what we don't always write in is this sort of imagined set of brackets. It's there, we just don't write it down because the division actually glues that together as something that can't be taken apart without dealing with the 4z, right? If we wanted to separate this, it would look something like this, and that's more clearly 2 terms, right? Okay, how about the last one? I think we can see here that that is 1 term, and we've got a second term there. So here we've got 2 terms. Okay, so number 4, just dealing with some definitions. Okay, so I've asked us here to identify the number of terms. So the number of terms here is 3. Okay, we've got 1, 2, 3. Now it's asking us what the coefficients are. So we haven't really said this yet, but the coefficient is always the number in front of or multiplying the variable. Okay, so I actually have 3 coefficients here, and if you've looked closely, I've actually done something wrong. Okay, the sign always goes with the coefficients. So in this case, we're going to write down that the coefficients here, okay, so the coefficient of x to the 5 is 4. The coefficient of x squared y is negative 17. Oh, and I made a mistake. Actually, we don't call this a coefficient because it has a special name. The fact that it is not attached to the variable, or any variable I should say, means that it is actually a constant term. Okay, so 3 here is our constant term. Okay, and what some people do is they say that, just to help them remember, it's the same as 3 times x to the 0. You don't need to remember that, but as we all know, x to the 0 is the same as 1. So if you want to write it as a variable, it is x to the 0, and that might help you remember. Okay, so let's look at number 5. Actually, I'm going to ask you guys to do number 5 on your own, and you can check the notes later. Number 6, polynomials are best written in descending order of, okay, so exponent on variables. Okay, so actually you probably didn't spend this very much time on this grade 9, but there is an order that we like. So in this case, I can see that the highest power is x to the 5. The next highest power is x to the power of 3. The next one is 7x squared minus 11. Now be very careful, like I just showed you, the coefficient includes the sign, so it should be negative 23 in that case. All right, what is a factor? A factor is a number and or variable that divides a polynomial evenly. And what does evenly mean? It means with no remainder, okay? So again, this is review. What are the factors of 12? Well, we know that all the numbers that divide 12 are 1, 2, 3, 4, 6, and 12, right? So for another thing I like to do is we can talk about factor trees, right, which I'm sure you've done. Or if I were to write out the factors of 12, I could also say it's 1 times 12, 2 times 6, and 3 times 4. Okay, so for one factor, there's always another factor. We call those factor pairs. Okay, so if I ever talk about a factor pair, it would be something like that. Okay, pair. All right, 105. Let's give this one a shot. Okay, so we know we've got 1 and 105. So I'm actually using my calculator for this. I'm dividing them both by 5, or dividing it by 5 because I know it's divisible by 5. It ends in 5. And now from here I can kind of see that 21 is a thing, so I probably can try dividing 105 by 3. So that works. 3 times 35. And I have a feeling 7 is going to work. All right. I'm pretty confident that these are the only factors. And the reason for that is if I look at a pair like, let's say this one, 7 times 15, well, 7 is actually a prime number, and 15 can be broken up in 3 and times 5, which appears here. Okay, so I know that I've included all my factors in all of these numbers. Okay, so I guess we can write the factors in order. 1, 3, 5, 7, 15, 21, 35, 105. All right, so how do we reduce fractions? So we're almost there, guys. How do we reduce fractions? Well, factoring is helpful. Okay, so for example, I can see that if I rewrite 18 as 6 times 3, and if I rewrite 12 as 6 times 2, well, I have a nice cancellation that happens here. Okay, so I end up getting 3 over 2. Okay, so 105, which, yes, of course, I got us to already do that one. So I can see that my denominator is 7 times 2, so I'm going to rewrite the numerator as 7 times 15, which I got from my factor tree. I'm going to divide that out, and my answer is 15 over 2. So I prefer improper fractions. I don't like, some guys want me to write this as 7 1/2. Okay, I'm not a fan. Just leave it like this, please. Okay, so let's do some practice. Okay, what is a like term? Another one that is going to come up a lot. Like terms are exactly the same variables raised to exactly the same exponents. Okay, and how do we combine like terms? So what we do with our like terms is to combine like terms, we would combine the coefficients of terms. Variables do not change. So that's a common mistake right there. So let's maybe put a star here. Okay, so for example, an error in this one, we can see that they are definitely like terms because they both have x raised to a power of 2. So the wrong answer here would be 7x to the power of 4. That's not right. We don't touch the variables. It's just 3 apples plus 4 apples is 7 apples is really the best way to think about it, okay? Same with this guy. This is just 5x to the power of 3. So the biggest challenge here is guys just not forgetting or remembering to that the variables don't change. All right, so we've got two things here that I want to go over with the distributive property. Okay, part one is pretty easy. Okay, if we have a times b plus c, we distribute by multiplying both of the things in the bracket by a. So it's a times b plus a times c. Okay, and recall that the multiplication of powers, if we have something like 2 to the 4 times 2 to the 8, that's just 2 to the 18. So we add the exponents. Okay, I'm going to give you a list of exponent rules in a minute. We're going to start off easy. Okay, with these ones, there's a 1 in front of these brackets if you don't see anything. If you distribute the 1, you can get rid of the brackets. And then we're going to simplify, and we do that by collecting like terms. Okay. So I've got minus 2x plus 7. Okay. So I'm going to skip number 4 and 5. You can check those in the notes. I'm going to go to number 6. Okay, just to remind you that if you have a variable here, so for example, 2x times x squared, well, x times x squared is x to the power of 3, isn't it? So we have 2x to the power of 3 minus 6x squared minus 8x, 6x cubed, minus 6x squared plus 15x. Okay, and then we would collect like terms. All right. Okay, so make sure you do 4 and 5 and check those. Okay, and I wanted to save the distributive property part 2 because I find that for number 8 especially, there's a specific way that works really well versus another way that might not work so well. Okay, so you might have heard the term FOIL, You can use FOIL. It only works for binomials multiplied by binomials, but essentially what we want to do is we take the a and we multiply both things in the second bracket by a. Okay, so we get a times c. And in this case, we're going to add because we just take the sign of the multiplication. So positive a times positive c is positive. Okay, and then, okay, we'll look at b. So b times c plus b times d. Okay, so it's pretty, this is review. I think if you, you spent a lot of time on this last year, you probably just need to shake off the cobwebs here, but you should be able to pick this up pretty quickly, I'd say. Okay, so beware here, this is negative 3y times 2x. So that's subtract 6xy. Negative 3y times negative 15y is positive 15y. Don't forget to square it. Okay, turns out here we only have like terms in the middle. Okay, so we've got 2x squared minus 11xy plus 15y squared. All right, so here's the one where I really want to guide you on. Common mistake is guys distribute the 2 first. I would highly advise against that. Okay, I just find it more error prone. If you are good at it and you do it all the time, great. But otherwise, what I'd advise for you to do is first simplify the 2 brackets. Okay, so we go from 2 sets of brackets to 1 set of brackets. 6x squared plus 8xy minus 9xy minus 12y squared. All right, so now we can distribute the 2, which is much easier than doing it first. So we've got 12x squared plus 16xy minus 18xy minus 24y squared. Okay, we've got like terms here. Alrighty. Okay, so let's move on to a couple of questions about operations with powers. Okay, so just again, dusting off those old cobwebs. How do I simplify when I multiply 2? So these are 2 monomials, okay? This is a single term, this is a single term. Together it's 1 term, okay? But we are multiplying, we're multiplying monomials here. So basically what I can do is I can think about this as multiplying all of these things together. And then I'm allowed, with multiplication, I can rearrange this however my heart desires. So I can see that I'm going to probably put these 2 together. I'm going to put these 2 together. And I'm going to put, finally, these 2 together. Okay, so what does that look like? Well, I have negative 4 times 3. I have a squared times a. I have b times b cubed. And guys, on a test, in your notes or whatever, in your homework, I would never do these steps, okay? You can go right from here all the way to here, and that's what I'm expecting. I'm just doing all these extra steps to help you remember. Okay, for number 10, we've got some division here. So what I'm actually going to do to help us visualize it is write it as a quotient like this. Okay, and then if you remember, when you have division like this, what you want to do is you group the like things. So I can see that these are coefficients, and I can see I have x squared here. They have the same variable, and I have y here. So basically, I just reduce all of these in turn. So I know 20 divided by negative 5 is negative 4. X squared over x squared actually cancels. And y4 over y2, I'm going to use subtraction there. Okay, so I get negative 4y squared. Okay, almost done. So here we go. We've got number 11 looks a lot like number 9, except for one very important detail. okay, and that is this guy here. So both of these brackets have exponents, okay, and what we know is that brackets and exponents come before multiplication. So I actually have to evaluate this, and this is where this rule comes in handy. So what that rule says is if I have negative 3x cubed yz all to the power of 2, what I have to do is take everything inside the bracket, okay, and raise it to the power of 2. Okay, so I'm actually not going to do all this work for the second one. I think we can figure out that it's negative 8 y9 x15 z 6. So you don't have to do all this work. But basically for the first step I wanted to show you, and don't forget the last thing we're going to use here is this rule. Okay, so I know when I have a power of a power, I just multiply the powers together. So negative 3 squared is 9, x6, y2, because there's actually a 1 there and a 1 there, z2, negative 8, y9, x15, z6. So what I'm going to do here is I'm multiplying the coefficients together. I get negative 72, and then with all the other things, I can just add the exponents, x to the 21, y to the 11, z 8. Okay, here we go. We're already at the last one. Look at that. 3x to the power of 4y. I'm going to get 4x 4z squared. Okay, negative 2 squared is positive 4. Okay, and the denominator is 8x4yz. Okay, and right now I could do some cancellations or whatever, but really the easiest thing for me to do is just create a single, do the operations on the numerator first before I cancel with the denominator. All right, so 12 over 8, we can't, that doesn't divide evenly, but what we can do is we can reduce this. Okay, so instead of actually dividing, we do this thing called reducing. So I know 4 goes into both of those, so I know I'm going to have 3 over 2. I can see x4 and x4. Oh, actually, all of these things divide out. Okay, so we can make this look a bit nicer. All right, guys, what I'm going to ask you to do is finish up those questions up there, and then you're going to go to the independent practice, and I will have solutions to those written up in our notes. Okay, so that is for you to have a look at, and yes, I will see you very soon.